Now we are going to tackle some problems relating to the previous lesson. So find the number of terms in the arithmetic progression minus 3, 1, 5, 9, 13 up to 237. So we want to know how many terms there are in this sequence. So if we are able to find which term represents 237, we will be able to know the number of terms in the arithmetic progression. Suppose this 237 is the 10th term. So we can conclude that there are 10 terms in the sequence because this is the 10th term. So in all we will have 10 terms. If this is the 25th term, so if this represents the 25th term, so we know that there are 25 terms in the sequence. So let's now find which term is 237. So we call it the nth term. So we say let the nth term be 237. Now we know that the nth term, that is un, is equal to a plus n minus 1 times d. So here we have 237, which is equal to the first term is minus 3 and the common difference is 4. So a is minus 3 plus n minus 1 times d, which is 4. Now we solve to obtain a value for n. (240) is equal to 4n minus 4. We can divide by 4. We obtain n minus 1 is equal to 60. So n is equal to 61. So we know that this n is a 61 term. Therefore, we can say that n is equal to 61. Number of terms is equal to 61. Now let's see a second method that can be used to find the number of terms. So if we know the first term and the last term, and also we know the common difference, so we must know the first term, the common difference, and also the last term. We can obtain n, that is the number of terms in the sequence, by taking the last term minus the first term, and then we divide by the common difference. In this expression, we add 1. So if we consider the above example, n will become, the last term is 237 minus the first term, which is minus 3, and then divide by d, the common difference, which is 4, and then at the end we add 1. So we will have 237 plus 3, which is 240, divided by 4 plus 1, and this gives us 60 plus 1, 61. So it is much easier, but we have to know the last term. The next example, the fourth term of an AP is 7, AP meaning arithmetic progression, and the 10th term is 16. Find the first term and the common difference. So we are given that the fourth term is 7. Fourth term, which we write as u4, is equal to 7. Using the formula for the fourth term, we can say that a plus 3d is equal to 7. This is equation 1. And we are also given that the 10th term is 16. 10th term, which we write as u10, is equal to 16. This implies that u10, which is a plus 9d, is equal to 16. So we have a second equation. Now we have to solve these two equations to obtain the first term, that is a, and the common difference, which is d. So here we can take the second equation and minus the first one. We obtain, so a cancel out, 6d is equal to 9. Therefore, d is equal to 9 over 6, which is 1.5. So substituting d by 1.5 into equation 1, this gives a plus 3 times 1.5 is equal to 7. We have a plus 4.5 is equal to 7. A is equal to 2.5. So the first term is 2.5, and the common difference is 1.5. So as you saw, we just have to apply the formula for the fourth term and for the 10th term. The first one is a plus 3d, and for the 10th term it is a plus 9d. And then we solve simultaneously. A third example, the nth term of an AP is 5 minus 6n. Find the first term and the common difference. So the nth term, which we write as un, is equal to 5 minus 6n. So we can find any term by replacing n here. If we have to find the first term, we replace n by 1. The second term, we replace n by 2. So to obtain the first term, we can write u1 is equal to 5 minus 6 times 1. When we have n here also we have n. Now when we replace n by 1, here also we must replace n by 1. So 5 minus 6 is minus 1. So this is the first term, u1. Now to obtain the common difference, we must find the second term, u2. u2 will become 5 minus 6 times 2. So we replace n by 2. We obtain minus 7. So this is the second term. To obtain the common difference, that is d, we just have to take u2 minus u1. It is the difference between two consecutive terms. So we obtain minus 7 minus minus 1, which is minus 6. So this is the common difference, and here we have the first term. So for the first term, we just have to replace n by 1, and we obtain u1. This is the first term. To obtain the common difference, we must find the value for the second term, u2. That is, we replace n by 2. and then we will obtain the common difference, which is u2 minus u1.